So we already talked about, basics of carbohydrate and lipid nutrition, sort of nutrition. And the third energy-bearing nutrient that can be found in the human diet, the protein. And the protein is characterized whether it is complete or incomplete. So complete proteins are either animal proteins or they come from soy. What does that mean for a protein to be complete? It means that it contains all necessary amino acids. Turns out that humans cannot synthesize 10 essential amino acids. You do not need to memorize 10 essential amino acids. Okay, but know that they exist, basically. Okay, so people who consume animal protein as the part of their diet receive all necessary amino acids. People who are strict vegetarians and do not consume any form of animal protein have to combine grains and legumes in order to obtain all essential amino acids. Does that make sense? Now, what about the high protein diets that some athletes use for muscle gain? Well, first of all, by itself, high protein diet will not lead to any muscle gain. You really need to exercise, but we talked about it before. The prolonged consumption of high levels of proteins will lead to acidification of blood due to the catabolism of proteins that releases significant amount of urea that has to be excreted. And urea production leads to the blood acidification. In order to neutralize the blood acidification, calcium from the bones will be spared, which may impair the bone integrity. So people who exercise excessive protein diet should also consider taking some kind of a calcium supplements. Okay. Now, the interesting thing about protein consumption and protein metabolism is that it follows so-called all or none principle. In order for the protein to be synthesized, in order for the protein in the cells to be produced, all amino acids have to be present. The protein itself may not contain all 21 amino acids, but if one or two are missing, the protein will not be made. Does that make sense? You understand what I'm saying? Think of it as a Lego set, which you can assemble only if not all kinds of pieces are in place. Your design doesn't have to include all the pieces, all kinds of pieces, but all kinds have to be present. Okay? Another obstacle and another consideration that has to be taken when people consume large amounts of protein during the intense exercise routine is that in order to build muscle, protein has to be consumed with the adequate amount of carbohydrates. Meaning that if you switch to entirely protein diet and exclude carbohydrates, you still need to get energy for ATP synthesis from something. And that something would be proteins that you eat. Does that make sense? So your protein will be used for muscle building only if the energy requirements of the organism are met, either via carbohydrates or fats. So for a successful muscle building, the person has to have a positive nitrogen balance, meaning that the person intakes more protein that is being digested. It can be measured by the amount of protein in the diet and the amount of urea excreted by the person. Urea being the ultimate product of protein catabolism, protein destruction. Negative nitrogen balance is seen in people where protein is used in catabolic processes. Say, we talked about stress response, right? The long-term stress response that involves release of the hormone called cortisol. When cortisol is released, it stimulates protein catabolism, breakdown of protein, and that leads to negative nitrogen balance. Okay. Hormones that increase protein synthesis, such as growth hormone or testosterone, thyroid hormone, they're called anabolic hormones. And hormones that lead to the protein breakdown, such as corticosteroids, cortisol, hydrocortisone, they are catabolic hormones. Where anabolism means synthesis and catabolism means breakdown. You're with me so far? As any nutritional recommendation, the amount of protein that should be consumed every day is not really based on any substantial evidence. It depends on what your goals are empirically. The empirical suggestion for people who want to increase the muscle mass is that the person protein intake should be at least 1 gram of protein per 1 pound of body weight. However, in like private conversations with people who actually practice bodybuilding, you will hear that it's not enough. So for, say, 180-pound male, you have to take in 180 grams of protein a day. This is a lot, like really a lot. So it's impossible to take that amount of protein with diet. I mean, with regular diet, with food. We're talking about protein supplements. This is why folks that exercise, they take protein supplements, because it's impossible. You cannot eat that much chicken or eggs or turkey. It's just physically impossible. Okay. This obesity is not really achievable. You cannot eat that much turkey. Okay. You can, if you focus on the protein in your diet, can lead to the bone loss. Okay. And since urea, that is the product of protein catabolism, is excreted through the kidneys, kidneys sometimes suffer, and increased high protein diet increases the risk for developing kidney stones. Okay. The deficit of protein manifests much easier. Growth retardation, wasting, anemia. In severe cases, it may lead to peripheral edema due to the abnormalities with the fluid balance. Okay? Now, that moves us to the discussion of certain nutrients that are not energy-bearing, okay, but are still essential for the person's survival. And the first in that list will be vitamins. Vitamins are organic compounds that are necessary for the proper execution of various biochemical reactions in the cell. They often serve as cofactors for various enzymes. And so vita means life, so they are essential for life. And the reason why we focus so much on those vitamins is because they cannot, the majority of them, the overwhelming majority of vitamins, cannot be synthesized in the human body. So we have to take them with food. Does that make sense? Vitamins can be divided into 2 large groups: water-soluble vitamins and fat-soluble vitamins. You can imagine that fat-soluble vitamins can be fairly easily not transported. They can diffuse actually across the epithelial barrier in the intestine. Okay. However, since they are fat-soluble, for the efficient uptake of fat-soluble vitamins, fat should be present in the diet. Does that make sense? And we'll address it a little bit more. Now, for water-soluble vitamins, you don't have to have fat in the diet, but they will be acquired usually by a facilitated diffusion or by transporters. Okay? Now, what is the difference? What is the fundamental difference in terms of the storage and metabolism of vitamins in the human body? Fat-soluble vitamins can be stored, can be accumulated in the human organism. Does that make sense? Do you understand what I just said? So if you eat a large amount of vitamin A every day, vitamin A will accumulate in the adipose tissue. Since it's fat soluble, it's going to be stored in adipose tissue, and it may lead to the intoxication. You can get intoxication. You can get vitamin poisoning. Water-soluble vitamins are not stored, and all excess is quickly excreted. Does it make sense? So we're going to start talking about fat-soluble vitamins first, and you need to know the role of these three vitamins in a human health. Vitamin A, vitamin D, vitamin K. Yes?
How would a person know when they're taking an excess amount of vitamins? Because like when you have a deficiency, it's normally shown through blood work. You might not necessarily feel the effects of it, but when it's an excess amount, how would you know?
Give me 1 minute. We'll talk about it. Okay? So, for fat-soluble vitamins, first of all, as we mentioned, they can be toxic. There are cases documented when people got poisoned by vitamin A. There was actually a pretty tragic and, well, ridiculous story when a woman who worked at a fairly small pharmaceutical manufacturing facility that was making vitamins found out that in the warehouse there were bottles with the sunflower oil. And there were indeed bottles with sunflower oil. The only thing that she didn't know is that that sunflower oil contained an enormous amount of vitamin A. It was the way to store it. And it was extract for like vitamin A pills for people with a deficiency. So she decided that if she grabbed one bottle of sunflower oil and bring it home, nobody would notice because there are like thousands of them. So she did, brought it home, cooked dinner, the entire family died. Because sunflower oil, that particular one, contained like several million lethal doses of vitamin A. Okay? Does that make sense? Now, how do you know if you have a vitamin, if you eat too much? There are dietary recommendations. Okay? Those are the symptoms of excess consumption of vitamin A. But let me put it this way. Unless you buy a bottle of vitamin A and chug half a bottle down, you're not going to have an excess. Specifically because practically all the food in the United States is enriched in certain essential vitamins like vitamin A and vitamin C. And we'll get to the idea of whether you should or should not take vitamin supplements. Is there any evidence that those supplements have any benefit, health benefit, okay? Now, vitamin D is produced in the skin, and vitamin K is produced by bacteria in the large intestine. Now, what are the symptoms? We're going to focus on the symptoms of deficits of the vitamin, and I will address the excess later. Is that okay? So, deficit of vitamin D leads to rickets. Vitamin D, as you remember, is necessary for the proper calcium absorption in the intestines, right? Vitamin D is produced by the skin when skin is exposed to the sunlight. So vitamin D can be taken as a supplement by people who are not exposed to sunlight or exposed very minimally. Let's say people who live and operate in the conditions of the polar night, for instance, or people who are, I don't know, I cannot think of any profession in darkness, really. Yes. Huh? Go ahead. Sure, yeah, yeah. You can, I am not sure. So, vitamin D is produced in response to UV specifically. So, you gotta have a component, the UV component in the light. I don't know if the lights that you use have that UV component. I doubt it. So, you may need to, well, in Ohio, you get enough UV exposure when you walk outside. Unless you enclose there for 18 hours.
I work in a funeral home and I never see the light of day, and I was recently diagnosed with a vitamin D deficiency, so now I have to take a supplement because it's really low.
Yes, that's possible. That's possible. What I'm saying is, even though the majority of us, we spend most of the time inside, okay, adults, unless it's extreme like in Jenna's case, and they're just being enclosed for a really long time, okay? Unless it's extreme, even walking to the car, walking around like grocery store, that should be sufficient, okay? But they can be imbalanced, absolutely. So vitamin A is taken with the food. All food in the United States, I believe, is enriched in vitamin A. Anything that's processed, okay, like bread, rice, should be enriched. You can take a lot of vitamin A from carrots. The condition is you have to take carrots with fat, meaning oil or really fatty dairy products work just fine. Okay. So vitamin A is necessary for proper night vision. Okay. If vitamin A is deficient, leads to nyctalopia in the developed countries, say in the United States. Dietary vitamin A deficiency is extremely rare. Vitamin K, phylloquinone, is a cofactor in the blood clotting. So deficiency in vitamin K will lead to defective blood clotting. Vitamin K deficiency is fairly unusual. Okay, that makes sense. So these three I reserve. So what I can ask you, which of the following vitamins is fat or water soluble? And for this, I want you to know all the letters. So I want you to know the A, D, E, and K are fat soluble vitamins. Everything else is water soluble. Am I clear? I reserve the right to ask you. The vitamin A deficiency will lead to. The vitamin D deficiency will lead to. Okay? So moving on to water-soluble vitamins. Now, it's going to be less than, let me see, anemia, scurvy. Yes. So the red rectangles highlight the vitamins for which I can ask you about the symptoms of deficiency. Do I make myself clear? Does that make sense to you? So I can ask you, the symptoms of vitamin B2 deficiency are, but I cannot ask you the symptoms of vitamin B6 deficiency are. All right? Good? Okay. So vitamin B1, beriberi. Deficiency in vitamin B1 manifests as the neurological condition that was first identified in Southeast Asia. The folks in Southeast Asia had this poor coordination, nerve degradation, basically peripheral neurodegenerative disease. And I don't remember the name of the scientist that actually discovered this vitamin, but the idea was that he compared the diets of people who had this condition and people who didn't have this condition. And it turned out that beriberi was fairly common in, if I may say, middle class farmers, but was much less common in poor people. Because poor people could not afford the properly husked rice, and they ate what we can call like a dirty rice with husks. You know what I'm talking about? Like, we buy regular, when you buy rice, it's a white rice. Does that make sense? But now, like, the brown rice is kind of fancy. It has this husks, it tastes terrible, but it's considered to be healthy. So these husks of the rice grains, they contain vitamin B1. And those poor folks, they were eating that brown rice, and they had no issues with beriberi because they consumed enough B1. Does that make sense? Now, vitamin B2 is a necessary component of electron transporters, electron carriers in the cell, like FAD and flavin mononucleotide. The deficiency of that vitamin leads to very characteristic cracks in the skin in the corners of the eye, of the mouth. Have you seen that? Especially in kids. The corners of the mouth, they have these cracks, really painful cracks, like sores. And one of the best treatments is to eat multi-grain bread. It contains a lot of vitamin B2. Folic acid and vitamin B12, two vitamins that are necessary for fast-dividing cells. Deficiency of these vitamins lead to anemia. The proper levels, dietary levels of these two vitamins are essential for pregnant women because they have another organism inside with a lot of fast-dividing cells. And without these two vitamins, those fast-dividing cells will not be fast-dividing. That's why pregnant women are often prescribed a vitamin supplement that contains folic acid and or vitamin B12. Does that make sense? People with genetic deficiency in intrinsic factor, which is a protein produced by chief cells in the stomach that is necessary for vitamin B12 absorption. Those people have anemia that is called pernicious anemia. Make sense so far? And probably the most famous, vitamin C. The deficiency of vitamin C leads to a condition called scurvy. So in scurvy, people usually develop poorly healing wounds. They lose hair. Skin becomes really scaly, and they basically have eczema. And scurvy is lethal if vitamin C levels are low enough for a substantial amount of time. Does that make sense? Now, what's really important about, going back to Jenna's question about excessive levels. You cannot have excess, again, normally, you cannot have excess of water-soluble vitamins unless you're chugging a giant bottle of vitamin C or vitamin B. Does that make sense? It's really not possible. However, and it's not possible because the excess of these vitamins will be excreted through the kidneys. However, that also explains why these medications, like 1,000 milligrams of vitamin C, are useless. Yes?
So is that why like those energy vitamin C things,
That's
tablets are
useless.
useless?
Spend it. How old are you?
I don't
Sorry.
use it, I just...
No. Well, I'm okay. Then spend it on the cake. I can't say spend it on the beer, so spend it on the cake. Basically, so going back to the idea of vitamins as nutritional supplements. Vitamins, first of all, are real nutritional supplements that some people need, like Jenna needs vitamin D. Okay? Pregnant women are often prescribed folic acid, vitamin B9. That's absolutely normal. Does that make sense? Now, there was a huge study about the effects of vitamin D on various conditions like cardiovascular disease, risk of developing cancer, and the recent results, so-called meta-analysis. So what's meta-analysis? You have, I don't know, several thousand hospitals in the United States, right? Say, I'm a doctor, I work in Lake Health, and I decide to do a study on the patients about the effects of vitamin D, okay? And I am cardiovascular doctor, all right? Not surgeon, just cardiovascular fellow. So I see people with different cardiac problems, and I tell them, look, take vitamin D. It's not going to hurt you, not going to feel worse, just take vitamin D. They sign consent, everything's fine. And then I have a population of people that don't do vitamin D thing. I treat them the same, all the prescriptions are, like same. But one group does take vitamin D, one group doesn't. And then I look at the outcomes in this group. Now, in another hospital, another group of scientists, group of doctors, they design the study maybe slightly different. Maybe they look only on women, or they look in men, or they look in children, or in older adults, or in people with congestive heart failure, or diabetes, or, So we have a bunch of very different studies. And then meta-analysis looks at all these studies and tries to find any common outcomes. And it's really hard because the cohorts that are studied in each separate approach, they can be quite different, The effects of something on men, middle-aged men, can be very different compared to the effects of something in adolescent girls. Does that make sense? You understand what I'm saying? But this meta-analysis looked at a lot of studies of effects of vitamin D, and the conclusion is very simple. Supplementation, diet supplementation of vitamin D in otherwise healthy people without vitamin D deficiency has no health benefits, period. So you're wasting your money. Okay? What about vitamin C? Energy thing. When do you take this vitamin C? Just for energy?
I've seen my dad take like in the morning.
I mean, it's okay, but the daily dose that you need is about 300 milligrams as far as I remember. This packet has 1,000 milligrams, which is 3 times more. 700 milligrams will go to waste. They will be excreted by the kidneys. A buddy of mine when he was in high school, he did a brave and a stupid experiment, and he chugged 3 grams of vitamin C, pure vitamin C, 10 times daily dose. The main outcome of that inhumane experiment, his pee was orange and smelled funny. That's it. This is it. So vitamin C is often advertised as the supplement that will help you to fight cold. No, it won't. There is absolutely no clinical evidence suggesting that vitamin C has any benefits in reducing the length of your cold symptoms or reducing the severity of the flu or anything. So don't waste your money. If you want to get some vitamin C, buy oranges. Or, I don't remember, broccoli or something like that has a lot of vitamin C. I don't remember. So, yeah, at least it has some taste. Okay. There was actually a pretty funny story. The idea that vitamin C helps to fight cold was thrown into the ring by American chemist Linus Pauling. He was a Nobel Prize winner, Nobel Prize in chemistry, really smart guy. But he wasn't a doctor. And he did a presentation of that vitamin C thing. It's a medical conference. He was like an honorary speaker. And when he finished, doctors were standing up and saying, "Nah, you're wrong. Sorry, I mean, we respect you, but you're wrong." A bunch of people said, "You're wrong." Session was over. And all these doctors ran to the closest pharmacy and bought all vitamin C there. Because, from medical standpoint, there's no evidence. But it's better safe than sorry. Linus Pauling says it. But you don't have to do it. What about multivitamin supplements? There is zero clinical evidence that multivitamin supplements have any effects, health effects, in otherwise healthy patients. Does that make sense? And I want to make it really clear. We're talking about healthy patients. If there is a person with anemia and folic acid, B12, iron, that's logical. Okay? Does that make sense? If you go on some kind of a weird ocean trip where you're gonna eat only fish, it's not a bad idea to grab that energy capsules, because vitamin C, you will not get it enough from the fish. Does that make sense? But in general, average American gets all the vitamins he or she needs from the diet, if the diet is fairly balanced, if you're not eating only fish. Does that make sense? So those vitamin supplements is a huge fat hoax, unless you need them. Am I clear? Unless you have clinical condition. Minerals. Well, when I say minerals, I'm not suggesting you need to start, gnawing on chalk or huge piece of sodium chloride, salt. You need to take some chemical elements in your diet. So I want you to know broadly the functions of calcium. Bones and blood clotting. We mentioned before, but abnormal levels of calcium, basically hypocalcemia, really affects the function of nerve and muscle, transmission of the nerve signal. Phosphorus, necessary for bone and tooth formation, and also phosphate buffer is a part of acid-base balance in the organism, mainly in the cells. So proper amount of phosphorus is also required. Sulfur. We take sulfur as the part of the protein, so we don't need that much. It's really hard to become deficient on sulfur. Potassium, chlorine, and sodium. We take those chemical elements in the form of ions. When, say, you eat sodium chloride, you get both sodium and chloride. And since usually sodium chloride, salt, contains some impurities, you may be taking potassium as well. Potassium is kind of weird, because potassium is very tightly regulated in extracellular fluid. So for instance, if you eat one banana, I believe it's like 2 or 3 doses, daily doses of potassium in one food, so you don't have to be concerned about proper potassium intake. Now, all of these ions are really necessary, so sodium, potassium, and chloride are essential for acid-base balance, osmotic balance, water balance. Does that make sense? One of the great examples is in certain situations when you have certain food poisonings, okay, absorption of sodium and potassium in the intestines can stop or can decrease. So sodium and potassium remain in the lumen of intestine. Does that make sense? Now, remember we mentioned that phrase, water follows what? Sodium. If sodium stays in the intestine, so does water. If water stays in the intestine, you have diarrhea. If you have diarrhea, you lose a lot of water. So that's your water balance. Does that make sense? Magnesium is a necessary enzymatic cofactor. Now, what you need to know about the deficiency. Calcium and phosphorus. That's it. Now here, I will be very, very precise about the micro elements that you need to know about, and I will focus my attention on them. Iron, necessary for the formation of red blood cells. Okay, that's first and foremost. I mean, it is a cofactor for many enzymes, but that's first and foremost. Iron deficiency leads to anemia. Makes sense, right? Fluorine, a component of enamel. So, low levels of fluorine in the diet lead to dental caries. This is why water in the United States, drinking water, tap water, is fluorinated. I mean, it's tested first because some areas have naturally high levels of fluorine, and then it doesn't have to be fluorinated. In some areas, water is fluorinated. Does that make sense? Zinc, necessary for the proper skin development. I want to put it first. Copper, we'll skip it. And here I want to focus your attention on the iodine. You already know that iodine is an essential chemical element for synthesis of thyroid hormone. So iodine deficiency leads to goiter. So far, am I clear? Those are the ones that you... So I'm not going to ask you about copper or manganese or chromium. Okay? I want to tell you the story, though, about selenium. Selenium is a trace element. Like, you really need very, very little. And you don't need anything, really. You don't need to take it. Does that make sense? You get enough selenium with food. You don't need any supplements. Okay? But when selenium was discovered as an essential part of certain proteins in the human, those proteins that selenium was a part of were necessary for neutralizing free radicals. Ever heard about free radicals? Okay, so-called reactive oxygen species. And one of the hypotheses about the origin of cancer is that high amounts of free radicals damage cellular DNA, which increases the chances of mutations, which leads to the carcinogenesis. And it was shown in mouse models and in cellular models that generating free radicals in the organism, increasing the, you can measure those free radicals, that increasing the amount of free radicals increases the chances of an organism to develop cancer. Am I clear? So then the line of thinking was the following. Selenium is the part of the proteins that fight those free radicals. Free radicals may cause cancer. What if we will increase the amount of selenium in the diet? Maybe it will help to fight cancer. Does that make sense? Pretty logical thinking. It was tested in mice, and in mice, results were not super amazing, but there was a correlation in mice between the amount of selenium, dietary selenium, and cancer frequency. So more selenium meant less chances to develop cancer. Pretty cool, huh? But remember, mice lie and monkeys exaggerate. So based on the results, a study called CELEX was initiated in the United States in 2000, I want to say 2001 or 2002. It was a massive study. Thousands of people. I think they enrolled something like 1 or 200,000 people in the study. People were taking selenium supplements every day, a certain amount. And there was a controlled group, of course, you know, so they compared frequency of tumors into groups of all cancers. In a couple of years, they had to stop the study because frequency of cancer cases in the group that received selenium was about 15% higher than in the group that didn't. Does that mean that selenium causes cancer? Absolutely not. In the group like that, it is possible, but that it definitely didn't decrease the frequency. Okay, so that kind of gives you an idea how hard it is to do a nutritional study. The effects are very often marginal. Okay, and you really have an enormous sample size. By the way, speaking of the fighting free radicals idea, sometimes vitamin C is advertised as antioxidant. First of all, from chemical standpoint, this is absolutely true. It is antioxidant. From physiological standpoint, you take more vitamin C, you pee it out. There's no point. It's not going to have time to fight your free radicals. Okay? As far as I know, people still push the idea about vitamin E. Here, vitamin E, tocopherol, being antioxidant. To my knowledge, there is no substantial evidence in humans that it does work this way. Am I clear? Now, before we move on, do you understand which vitamins I want you to know in terms of deficiency? Do you understand that I may ask you a question, which of the following vitamins is water or lipid soluble? And I can ask about any, but that's it. Like, I can ask, vitamin E is, think, okay, A, D, E, K. Those are 4 fat soluble. That's all I need to know because everything else is water. Clear? And in terms of the chemicals, calcium, phosphorus, bone, potassium, sodium, chloride, water balance, acid-base balance. Here, this 5, iron, fluorine, zinc, iodine. 4, I'm sorry, I'm not going to ask about selenium. Iron, fluorine, zinc, iodine. Know what happens in case of deficiency. Any questions? So good? Now, we getting into the part that we'll just start. I'm not going to go any further than this, okay? Because next conversation will be really long. But I want to give you an overview of what we're going to be talking about on Thursday and partially next Tuesday. We're going to be talking about metabolism and the connections between different metabolic pathways. So metabolism includes all chemical reactions in the human body. All of them. And chemical reactions can be broadly separated into catabolic, which is degradation, and anabolic, which is synthesis. So when you consume starch and amylase, the enzyme amylase, breaks down starch in your mouth, it breaks it down into smaller pieces. Starch is catabolized in your mouth. Is that clear? When amino acids are taken into the cells, muscle cells or liver cells, and used for the synthesis of glycogen, glycogen synthesis is anabolic reaction. Does that make sense? Do you see the difference between catabolism and anabolism? Okay? So all the reactions that are catabolic, reactions of breakdown, usually occur with the release of energy. We call reactions that produce energy exergonic. Ex, outside, ergo, energy. Does that make sense or not? I will give you an example. Now, the energy that is released in exergonic reactions will be usually used for the synthesis in the endergonic reactions. So let me give you an example. Say you eat sugar, sucrose. Sucrose is initially catabolized or broken down. You can write it down. Sucrose is broken down into glucose and fructose. Now, glucose is then broken down in glycolysis and Krebs cycle to carbon dioxide and water. Now, this process releases energy, and this energy will be used to synthesize ATP from ADP and inorganic phosphate. And then energy that is, so think about this. This reaction, glucose breakdown, is catabolic. Does that make sense? It's catabolic, it's a breakdown. Make sense? And it's exergonic because it produces energy. The reaction of ATP synthesis is anabolic and endergonic because it's a reaction of synthesis and it requires energy. Does that make sense to you? When you break down the chemical, like protein or carbohydrate or fat, breakdown will release energy. Usually catabolic reactions are exergonic. Okay? When you synthesize something, like a protein or a fat, you need energy. So reactions of synthesis, anabolic reactions, are endergonic. They will require energy. Does that make sense? So we will be talking about how human body catabolizes carbohydrates, lipids, and proteins in order to release energy so that energy can be used for the ATP synthesis. Yes?
So the glucose breakdown is catabolic and exergonic.
Correct.
Because it creates energy.
Because energy is released, that's why it's exergonic. And it's catabolic because it's a breakdown.
Okay. And then the ATP is
Synthesis,
endergonic and anabolic.
yes,
It uses energy.
and uses energy, and its synthesis, this is why it's anabolic. Does that make sense? Question, Aaron.
Yeah. What is that squiggly line that looks like a circle and an E?
Oh, the squiggly line? That's an arrow, and E means energy.
Oh, okay, great.
Sorry. Does that make sense?
Yes.
Now, last thing that I want to mention, efficiency of all these energy transfers from exergonic to endergonic, efficiency is less than 100%, so we constantly lose energy. Well, we're not really losing it. This energy is heat. This is why we're warm-blooded. Okay? We manage to have pretty intense metabolism that allows us to maintain more or less constant body temperature. Make sense? I will see you on Thursday.